The fog over Lorraine that morning did something no German staff officer had ever managed. It made a Panther tank crew feel blind and slow. September 1944. Near Arracourt in eastern France, a column of Panther tanks from the 113th Panzer Brigade edged forward at walking pace, their commanders squinting into a gray wall that swallowed everything beyond 30 meters. These were veterans from the Eastern Front, men who had lived through the furnace of Kursk in Ukraine. They had been told again and again that German armor was superior, that American tanks were clumsy, undergunned, and manned by amateurs who needed numbers to win. Then, in that fog, something happened that did not fit any pre-war lecture, any training film, any experience from Russia. A tank destroyer appeared out of the mist where no tank should have been, moved sideways like a racing car instead of a lumbering tracked box, fired twice in rapid succession, and vanished. By the time the Panther gunner could drag his 7-ton turret around, another Panther 50 meters away was already burning. The enemy vehicle had been in sight for only seconds. It was as if artillery shells had suddenly grown engines and a sense of timing. What those German crews were really seeing was not just a new vehicle. They were watching a different idea of armored warfare collide with theirs, an idea built around speed, information, and kill rate, not armor thickness. To understand how a thin-skinned American race car with a gun could humiliate Germany's most feared tanks, the story has to move back to the winter of 1941 to a quiet office in Maryland. Lieutenant Colonel Andrew Davis Bruce did not look like a revolutionary. At Fort Meade in Maryland, he studied German blitzkrieg reports with the calm eye of an engineer rather than a tank romantic. He saw the same facts everyone else did: fast Panzer spearheads, combined arms, breakthroughs in Poland and France. But Bruce drew a very different conclusion. If tanks were now the spearhead, he asked, why meet them head-on with other heavy tanks? Why not develop a weapon that could move faster than any tank, strike from better angles, and disappear before the enemy could react? Instead of armor against armor, make time and geometry the decisive protection. From that simple, almost impolite question, American tank destroyer doctrine was born. Bruce laid out his priorities in an order that would have been heresy in any German design office. First, speed. Second, firepower. Third, crew efficiency. Armor protection, the sacred cow of European tank design, came a distant fourth. Tank destroyers would not stand in the line. Like mobile pillboxes, they would be held in reserve, marshaled like a fire brigade, rushing to counter enemy armor wherever it appeared, using speed to hit flanks and rear, then shifting again, before the enemy could bring weight to bear. Faith cannot armor steel. In Germany, the answer to the Soviet T-34 had been the Panther. Heavier, thicker, more complex, with more sloped armor and a long high-velocity 75mm gun. The path was linear, more of what had worked before. In the United States, the answer became something else entirely, a 20-ton chassis with an aircraft engine, an open turret, and just enough armor to stop small arms fire, but capable of highway speeds that looked absurd on paper. The vehicle that emerged from Buick's design studios in Flint, Michigan, under automotive styling legend Harley Earl, hardly looked like a tank at all. A low, sleek hull, torsion bar suspension instead of complicated interleaved road wheels. A 9-cylinder Wright R975 radial aircraft engine producing roughly 350 to 400 horsepower. The same basic engine powered the 33-ton Sherman. In the Hellcat chassis, it only had to push about 20 tons. That power-to-weight ratio changed everything. On test tracks, the new tank destroyer, eventually standardized as the M18 and nicknamed Hellcat, could reach 55 miles per hour, with some crews insisting it could touch 60 under ideal conditions. On broken ground, it could still maintain around 40 miles per hour where most German tanks had to slow to 10 or risk throwing a track. Its turret weighed a little over 2 tons and could swing onto a target in seconds. In contrast, a Panther's 7-ton turret, driven by hydraulics that depended on engine revolutions, might take a full minute to rotate 360 degrees in combat conditions. On a black and white test film, the differences looked almost comical. A big German cat slowly muscling into position, and a light American destroyer that seemed to flick from target to target like a nervous bird. Underneath that speed was another kind of advantage: information. Every Hellcat carried an SCR 508 frequency modulation radio, giving each crew a clear voice network to other vehicles and to supporting units. German tank platoons usually had one radio set, in the platoon leader's tank. The rest relied on flags, hand signals, and prearranged plans. When things went wrong, the Germans shouted inside steel walls. The Americans talked across the battlefield. The M18's first taste of combat came in Italy, at Anzio in the spring of 1944. 5 early T-70 prototypes went to the 894th Tank Destroyer Battalion. The terrain was anything but ideal for a high-speed vehicle: narrow roads, broken hills, mud. Even so, German defenders were stunned to see a tracked vehicle maneuver that fast while still placing accurate 76mm fire. Yet those early lessons stayed localized, locked in reports that did not reach Panzer brigades redeploying to France. By the time the fully equipped 704th Tank Destroyer Battalion linked up with the 4th Armored Division in Lorraine in September 1944, German intelligence still thought in terms of Shermans and the older, slower M10 tank destroyer. The 113th Panzer Brigade, formed on the 4th of September and committed to the sector on the 16th, rolled in with 42 Panthers and the conviction that they were the hunters. On paper, that confidence made sense. Each Panther cost roughly 117,100 Reichsmarks and soaked up close to 2,000 man-hours of labor. It carried up to 100 millimeters of armor on the turret front. It was the pride of German industry. The Hellcat, by contrast, cost about $57,500 and took roughly 500 man-hours to assemble on a Buick production, lined by workers who had been building civilian cars a year earlier. Armor was thin enough that crews joked about being protected only against angry French farmers with rifles. The German way of war: trusted armor. The American way, at least in this corner of the conflict, trusted systems. Before dawn on September 19th, Company C of the 704th settled into positions near Arracourt La Petite along the approaches to Arracourt. Engines idled low. Crewmen in their open turrets scanned the fog with binoculars and naked eyes. Lieutenant Edwin Leeper, leading one Hellcat platoon, understood that his real weapon was not just the 76mm gun, but time, the seconds his crews could steal from the enemy by moving and aiming faster. Around 07:15, the Panthers began to feel their way forward at about 5 miles per hour, drivers straining to see anything beyond that white wall. Each commander hunched in his cupola, trying to read a battlefield that simply was not visible. Then one of them saw it, the stub of a gun tube emerging from the fog only 30 feet away. That moment, recorded later in after-action reports, reads almost like a jump scare. Leeper reacted first. He deployed his platoon, and suddenly the quiet field turned into a geometry problem. One Hellcat gunned its engine and leapt from cover, claws biting into wet earth, accelerating from a standstill to 30 miles per hour in seconds. The Panther opposite heard it before anyone saw it clearly, a rising engine note, much higher pitched than the deep growl of German Maybach engines. By the time the German gunner swung his turret and tried to find the target through the gun sight, the Hellcat was already off to the side, gun laid onto the Panther's exposed flank. 2 shots, 2 penetrations. The German vehicle's thin side armor could not shrug off 76mm armor-piercing rounds. Flames boiled out of the engine deck. Crewmen who had been told American shells would simply bounce now grabbed for hatches. In roughly 5 minutes of fighting that morning, 5 German tanks from the 113th Panzer Brigade were knocked out. The Americans lost a single Hellcat. The numbers themselves were shocking, but what unsettled German crews was how little control they seemed to have. By the time one Panther crew could even identify where a shot had come from, that Hellcat was already changing position based on a radio call from another crew, moving to exploit a gap, racing along a hedgerow, or slipping back behind the crest of a hill. They were not fighting individual tanks. They were being hunted by a network. As the fog began to thin toward mid-morning, the full pattern of the American defense emerged. The combat command had not simply scattered tank destroyers at random. It had built a thin but intelligent web of armored infantry outposts. Engineers, Shermans, artillery, and mobile Hellcat platoons waiting behind the line. Captain Tom Evans used one platoon as a visible lure while others slid out to the flanks. The Germans obligingly focused on what they could see and missed the guns they could not. The German weaknesses were technical and human at the same time. Final drives on many Panthers, originally engineered for a lighter 35-ton design, failed under the stress of trying to accelerate and turn on broken ground. Several tanks had to be abandoned in that fog not because a shell had hit them, but because gears had simply shredded themselves. Crews climbed out into the damp morning, listening to unseen engines of American vehicles they could not catch. Inside the Hellcats, the picture looked different. The torsion bar suspension gave a relatively smooth ride, even at speed. The torque converter automatic transmission, adapted from Buick civilian designs, freed drivers from wrestling with clutches and double shifts. Gunners and commanders could keep their eyes out and their minds in the fight instead of worrying whether the engine would stall on the next slope. Early reports from tank destroyer battalions spoke in very plain language. These vehicles could go hundreds of miles under harsh conditions without major repair. Routine maintenance was simple. Engines sat on rollers so they could be disconnected and slid out onto the lowered rear deck. A trained crew could change an entire power plant in less than 2 hours. On a Panther, the same job consumed most of a day and required skilled mechanics and special tools. The difference was not glamorous, but it drove kill rate just as surely as gun performance. By noon on that 19th of September, the attack of the 113th Panzer Brigade had bogged down into confusion. Here and there, Shermans, originally dismissed as easy prey, flanked Panthers whose attention was fixed on the more obvious threats. 11 German tanks were destroyed by those supposedly inferior supporting vehicles, their side armor laid bare by poor deployment and poor reconnaissance. The fog that had seemed like a friend now behaved like an accomplice of the Americans, hiding rapid movements and revealing German silhouettes only when it was too late. The day produced individual stories that became legend. Inside the 704th, Sergeant Henry R. Hartmann, commanding a Hellcat, accounted for 6 German tanks, most of them Panthers. He did not do it by sitting in a hull-down position and trading shots. He used every fold of terrain, every dip and hedgerow, to work his way to flanking ranges where the Hellcat's gun could strike the narrow gap between the Panther's mantlet and glassy plate. A round placed there tended to ricochet down into the driver's compartment, killing or disabling the crew. In a slower vehicle, at closer range, this would have been suicide. In a 55-mile-per-hour Hellcat, it became calculated risk. As the battle around Arracourt stretched into the following days, the pattern repeated in different forms. On September 22nd, Hellcats sprinted across open fields toward German positions near Coincourt at what looked, to the men in the Panthers, like reckless speed. They heard the oncoming engines, tried to traverse, tried to lead their shots, but most rounds went behind the targets. The American vehicles covered the distance in less than a minute. When they stopped, it was only long enough to fire, then accelerate again. The psychological effect was cumulative. German crews accustomed to being the hunters now waited for invisible predators operating on shorter decision cycles than anything they had trained for. They had fought Soviet T-34s, heavy KVs, even dug-in anti-tank guns. None of those enemies had been able to appear and disappear so quickly while still placing accurate fire. They didn't just lose a battle, they lost their idea of the world. Senior commanders eventually saw the problem in cold numbers. By the 25th of September, as the fight in Lorraine dragged on, German reports tallied 39 Panthers lost to the Hellcats of the 704th for only 4 M18s destroyed and 3 damaged. In industrial terms, more than a week's worth of total Panther production across all front allocations had been effectively erased by one American battalion. An American factory could replace those Hellcats in less than 2 days of normal production. Abundance, not ideology, won the war. The reaction from higher headquarters was sobering. General der Panzertruppen Otto von Manschufel, commanding 5th Panzer Army, issued instructions acknowledging enemy tank destroyers of exceptional speed in the sector and warning his armored units not to pursue and not to engage in mobile battle. In other words, Do not chase the Hellcats. The Panther, designed as an offensive, mobile weapon, was being reduced on paper to something closer to a static strongpoint. A tank meant to roam and dominate the battlefield was being told to sit still and wait. It was an admission that the old German formula, armor, firepower, and deliberate movement, had met an opponent it could not comfortably outthink. The story did not end at Arracourt. In December 1944, as German forces launched their last great offensive in the Ardennes, Hellcat-equipped tank destroyer battalions again used speed in a way no German staff college exercise had fully explored. Task forces like Team de Sobry of the 10th Armored Division raced along winter roads to plug gaps and form blocking positions at places like Noville. In one of the few documented cases, M18s actually used their peak road speed to get ahead of an incoming Panzer force and dig in before the first German tanks arrived. Across that bitter winter, Panthers and Tigers repeatedly found themselves confronting American vehicles that had already taken up position, already coordinated with infantry and artillery, already talking to each other on reliable radios. The German timetable, the heartbeat of any offensive, kept slipping, not only because of snow and fuel shortages, but because the enemy had learned to move, concentrate, and redeploy faster. By the time the war in Europe ended, the M18 Hellcat had claimed around 526 enemy vehicles destroyed for 198. In Europe, 17 in Italy, 11 in the Pacific, for the loss of about 216 of its own in combat. The overall kill-to-loss ratio of roughly 2.4 to 1 made it the most efficient American armored vehicle of the war in that metric. That statistic is even more striking when set against the fact that Hellcats were often pulled into improvised roles, direct fire, support for infantry, ad hoc assault guns, well outside their original doctrine. Those numbers did not come from speed alone. They came from the interaction of speed, information, doctrine, industrial reliability, and human training. The Hellcat's crew sat in an open-top turret exposed to weather and shrapnel. Their survival depended on understanding their machine and their doctrine, on trusting each other's voices over the radio, on reading terrain quickly. They were, in a real sense, the sensors of this system, feeding observations into a network that turned into firing solutions and flanking moves. The Panther crews, by contrast, often fought inside narrow cones of awareness defined by periscopes and vision slits. Without widespread radios, each tank commander had to interpret the battlefield in isolation. Even the best optics could not overcome a lack of timely information. Armor thickness and gun penetration tables did not help when the enemy simply refused to be where old training manuals said he should be. Behind those tactical differences lay two industrial philosophies. German factories, battered by bombing and starved of critical materials, built Panthers that were, in many respects, handcrafted machines. Maybach engines required careful assembly by skilled craftsmen. Interleaved road wheels took time and labor. Each extra millimeter of armor plate demanded alloys that were increasingly hard to obtain. As the war went on, these machines became more capable on paper and more fragile in reality. American factories approached the Hellcat as an industrial product first, a weapon second. Wherever possible, designers used standard automotive components. Production at Buick's Flint plant ramped up quickly after July 1943, peaking in January 1944 at around 250 vehicles a month. From concept to combat deployment took less than 2 years, an astonishing pace for an entirely new armored fighting vehicle. The chassis proved so sound that, in the Korean War, around 650 early Hellcats were converted into M39 armored utility vehicles simply by removing the turret and fitting seats. The hull, engine, and suspension kept doing useful work long after the original doctrine had faded. In the 1950s, former Wehrmacht officers serving as advisors to the new West German Bundeswehr evaluated Allied armored concepts for the Cold War. Almost unanimously, they advised against overly heavy tanks and urged a focus on mobile systems. Their memories of Lorraine and the Ardennes were not abstract. They remembered turbines of fear starting the moment an unseen enemy engine revved to life and a thin-skinned destroyer burst from cover, where no tank was supposed to be. Decades later, At a reunion near Arracourt in 1985, German and American veterans walked the same fields where fog once hid racing silhouettes. Photographs from that day show old men standing together, watching a restored M18 streak across a meadow. Even 40 years on, the little tank destroyer still hit a top speed that seemed wrong. For tracked steel, some of the Germans watched in silence. They knew, maybe more clearly than anyone else alive, that the machine passing in front of them had once turned their proud Panthers into burning wrecks in minutes. Modern main battle tanks like the American M1 Abrams, the German Leopard 2, or the Israeli Merkava are worlds away in weight and protection from the M18. Yet their doctrines, emphasizing mobility, situational awareness, and combined arms integration over sheer armor thickness, carry the fingerprints of those September days. They are designed to move, to connect, to sense and decide faster than the enemy as much as to absorb hits. The Hellcat did not end the age of the heavy tank, but it did prove, in the most brutal way possible, that speed, information, and reliability could rewrite the math of battle. For German crews in 1944, the first encounter with the M18 Hellcat was a shock. For historians, looking back across faded after-action reports and grainy photographs, it marks a turning of the page, the moment when one philosophy of armored war, born in the mud of the First World War and refined in the early blitzkriegs, ran headlong into another that treated mobility itself as a kind of armor. In warfare, as in evolution, it is not always the strongest that survives. Often, it is the most adaptable, the side that can think differently about speed, risk, and how much information a crew can handle in 10 seconds of chaos. On the foggy fields around Arracourt, a thin-skinned American tank destroyer proved that faster thinking, supported by faster machines, could turn hunters into hunted. The Panthers burned, the Hellcats kept moving, and the idea of what? An armored vehicle could be moved with them